If you're preparing for 9709 paper 3 and you keep losing small but important marks, it's usually not because the topics are too hard. It's because of small structural mistakes that repeat under exam pressure. So in this new series called Why You're Losing Marks, we'll identify those patterns and fix them, one topic at a time. Today, we're starting with logarithms. If you're losing marks in logarithms in 9709 paper 3, it's usually not because of algebra mistakes. Today, we're going to tackle 4 common mistakes that students make with logarithms, and we're going to fix it once and for all. The first mistake has to do with incorrect expansion. So let's take an example. Ln x minus 4. Now the tendency with students is to expand this logarithm to ln x minus ln 4. Now this is what you do in algebra, but this isn't algebra, it's logarithms, and this is wrong. The actual log law that we use is called the multiplication law. What does the multiplication law do? If you have a log with 2 terms multiplied inside it, so for example, if you have 4 into x, you can split it up into log 4 plus log x. And we have a division law which says if you have a log of, let's say, 4 divided by x, you can split it up into log 4 minus log x. But the example here that we see is log of x minus 4. So it is neither multiplication nor division, and therefore the log laws don't apply here. And this is the first of the mistakes that students make when they are trying to apply log rules to logarithm questions. The next mistake we want to talk about has to do with domain errors. So let's take an example. Log of 2x plus 4. Now, if you see log of 2x plus 4, the first thing you need to ask yourself is, what is the domain for this log? So what does that mean? Now, you can never have a log of a negative number. So this entire section within the log has to be positive, right? So 2x plus 4 must be greater than 0, which means that 2x has to be greater than negative 4 and x has to be greater than negative 4 by 2. So x is greater than negative 2. Now, if the solution that you get, so let's say you solved an equation involving 2x plus 4 and you found that x was equal to negative 3. You need to be aware that since our domain told us that x has to be greater than negative 2, this is an invalid answer. And therefore, it must be discarded. So that's the second mistake that we forget to make. When you're given a log equation, check the domain for all the logs given to you. So sometimes an equation will have multiple log expressions. Check the domain on all of them. And when you get a final solution, make sure that you cross-check. This brings us to our third mistake, not verifying the final solution. So all of your algebra might be correct, but if you forget to verify the final solution, you'll end up losing 1 mark at the end for your answer. So let me show you. Log x minus 4 is equal to log 2 minus x. Okay, so let's say this is the equation that's been given to us to solve. So what do we know? We need to check the domain right in the beginning. So x minus 4 has to be positive, so greater than 0, which means that x has to be greater than 4. And then there's a second log given to us, which is 2 minus x. That has to also be greater than 0. So x has to be less than 2. Right? So this is what our domain is. X has to be less than 2 or greater than 4. So let's check out the solution here. Since it's a log on both sides and there's a single log on both sides of the equation, we can just equate x minus 4 is equal to 2 minus x. Now when we simplify this, we get 2x is equal to 6 and x is equal to 3. Right, algebra done, we've got a solution. But is this the solution? So for that, you need to go back and plug the value of 3 back into your original equations. Check the domain. Does it fit into the domain? So is x greater than 4? No. X less than 2? No. So this particular equation has no solution. Why? Because the two solutions that you got do not satisfy the original equation. Last mistake has to do with misusing log laws. Now I'm going to give you an example of how log laws are misused. It's also going to cover some of the other errors we've talked about earlier. So solve log x squared plus 1 is equal to 1 plus 2 log x. Right. So here you have two logs which can be combined. So we're going to avoid the first error that we talked about, which is we will not be expanding log x squared plus 1 to make it log x squared plus log 1. Okay, that is a big no-no. Instead, we're going to combine both the log terms. So log x squared plus 1 minus 2 log x. So I've brought both the log terms to the left and I've left a constant 1 on the right. Now, how to combine these two logs? So we can see the minus sign in between. It looks like the division law. But what do you do with the 2? So the tendency is to just do a log x squared plus 1 and maybe divide it by 2x. This again is a mistake. So what you need to remember here is if there is a multiplier for a log, such as the 2 here, you want to use the power law to first take the 2 inside the log. So what does that mean? We'll be doing log x squared plus 1 minus, and instead of 2 log x, use the power law and take the 2 inside the log function and make it x squared equals 1. Now we're ready to apply the division law. So the division law says if two logs are subtracted, you can combine them into a single log with a division inside it. So now we're going to combine these two and make it log x squared plus 1 by x squared is equal to 1. Right? So now we have a single log on one side and a constant on the other side. We're not going to do any kind of expansion here anymore. We're going to straight away convert it into an exponential equation. Okay, So for an exponential equation, what you need is a base. So since it's ln x squared plus 1 over x squared, the base is understood to be e. And the formula for converting a log into a log equation into an exponential equation is if you have log a base b is equal to x, to convert it to an exponential equation, all you have to do is take the same base, raise it to the power x, and that is equal to a. Okay, this is how you convert from a log equation to an exponential equation, and vice versa. You can do it both ways. Right. So here we're converting the log into exponential. Take the base e, raise it to power 1, and you get x squared plus 1 by x squared. We have discarded the log. Right, now we just have to solve it. So to do that, it's plain algebra. We have to solve for x. So first take x squared from the denominator over to the other side. So we get x squared into e is equal to x squared plus 1. I want to make x the subject since I'm solving for x. So bring all the x squared terms to one side. Factorize the x squared out so that you can isolate it. So e minus 1 in the bracket. And then x squared is equal to 1 by e minus 1, which means that we square root both sides to get x is equal to plus minus root of 1 over e minus 1. Now, what we see with this is you get two solutions. I've gone ahead and calculated those values, plus minus 0.763, rounded off to three significant figures. Right, so we did the algebra, solved the equation, we've got x. What have we forgotten? We've forgotten to verify the answer with the original equation. So our original equation says, where is it? Log x squared plus 1 is equal to 1 plus 2 log x. There are two log terms. The first one is log x squared plus 1 and the second one is log x. We have forgotten to look at the domain. So x squared plus 1 has to be greater than 0 and x has to be greater than 0 based on the two logs given to us originally. Now, x squared is always going to be positive because it's a square term, and if you add 1 to it, it's still positive, right? So either negative 0.6763 or positive 0.763 would work for this equation, right? However, x has to also be greater than 0. In that case, negative 0.763 would not work. Therefore, the solution is only plus 0.763. If you were to write plus minus 0.763 because you forgot to look at the domain and you forgot to cross-check or verify your answer, in that case, you would lose the entire solution mark. There is no half marks, right, on your 9702 paper 3. So just be very careful. Check the domain and also verify your answer with the original equation. That's the end of our first episode in the series, Why You're Losing Marks in 9709 paper 3. In our next episode, we're going to be talking about mistakes, common mistakes that you make in your modeling curves section of the log chapter. See you there.